So this unit is all about transformations. And what are transformations?
I have no idea.
Well, let me tell you. A transformation, yeah, there are certain ways for it to transform. Okay. Basically, here's what we're doing with this. I'm taking this figure. It's called a pre-image, this figure that we start with, and this is a transformation. That's a reflection. That's right. This right here is a translation. Yeah. And this, guess what this is? It's a rotation. So it's a drunk triangle. So, guys, that's what we're doing. We're doing transformations. So let's talk about what those transformations mean over here. All right. A transformation is a change in size, location, and or direction. You saw that I was changing sizes. You saw that I was changing locations. And I was also taking that figure and then putting it in a different direction. Okay. The other thing about this is isometry. Now, when we're talking about when we say isosceles triangle, what do we know about the two sides of the isosceles triangle? They're all equal. Exactly. All right? So those two sides of the isosceles triangle are equal. So that means the same. That means they are the same. Now, that metry means that it's our word for measure. Like geometry means measure the earth. So it's going to have the same measure. Isometry is a transformation that doesn't change size or shape. And then finally, a reflection is just a mirror image across a line. You guys have seen reflections literally hundreds of thousands of times. Every time you look in a mirror, you see a reflection. So let's take a look at this. Example 1, reflect this image across line M. So I want you to take a corner of your patty paper and I want you to lay it down on that image right there, and I want you to trace that image onto your patty paper. And give it a good amount of lead. We want a good amount of lead on there. Don't just do it kind of lightly, mamby-pamby. I want you to give it a good amount of lead. Don't do it mamby-pamby. I want you to give it a good amount of lead when you're tracing. Also, I want you to trace this line, M. And then put little bullet points right where the arrows are. That'll help you out, because once you're done with that, you're going to take your patty paper and you're going to flip it. Flip it. Flip the patty paper. You're going to line up your bullet points in your line on M. And once you get it just right, you'll have your reflection. Not too shabby. Oh, so here's what you need to do with that. Now that you've lined it up, I want you guys to take your pencil and then trace over it, like press pretty hard. Don't tear the patty paper, but press pretty hard. Trace over your triangle. And if you need to, you can kind of color over your triangle with your pencil. But the idea here is to transfer that graphite that's on the patty paper onto your pencil. Onto your paper. So when you pick your patty paper up, then you're going to still have that trace of the triangle, and then you can color in that triangle a little bit more on your patty paper. And lastly, we're going to take a look at the two vertices on each image, the little corresponding vertices, and then connect those dots. What do you think you can tell me about the angle that's made by the reflection? Yeah, the line of reflection and the corresponding line there is indeed 90 degrees. And also, what can you tell me? You may not know the length of this segment and that segment, but what can you tell me about those two segment lengths? Exactly. They are equal and they are perpendicular to that line of reflection there. Good. All right. Also, it says the pre-image maps to the image. All that means is that we start with the pre-image and then we create an image. So the pre-image is the old, or it's the before. So the one we started with is the pre-image. If you're looking at a mirror, your face is the pre-image. Exactly. The thing you see in the mirror is the image. The image is the new, or the after. And we've just labeled those two triangles. So remember, the image is after the transformation, much like when you see one of those before and after weight loss pictures. The image is the after. All right. So let's take a look at example 2, reflected across the line M. I'm going to put my patty paper on that, another corner of that patty paper there. I'm going to trace my M, put little bullet points at the arrows, and then I'll trace my image. And after I do a good job getting all that graphite on the patty paper, I'm going to flip the patty paper and then lay it down. And then remember, I'm going to trace over that image on my patty paper and try to transfer that graphite onto the paper. Okie doke. Not too bad. Let's do that one last one, the arrow. The arrow is a little bit different because you see that the shape is actually overlapping on the axis that we're trying to reflect this around. Yeah. Yeah, you can use patty paper for the problems on your homework.
So do we just like get one?
Uh-huh. Yeah, you can grab a patty paper or two on your way out. That's fine. Well, actually, you'll be able to do a little bit of that homework. Thank you. You'll be able to do a little bit of that homework today in class.
Do you have to use patty paper?
You don't absolutely have to, but here, let me show you the other way.
Okay, I forgot to grab some, so I'm just drawing it.
Yeah, I don't want you just to draw, but here's the other way you can do it. You can say, I see this point right here, and I'm going to draw a little line that's perpendicular and the same length, and here's my new point, and do the same thing with this point. Line, perpendicular, there's my new point. Perpendicular line, same length. There's my new point. I'll show you how effective this is in just a second. Allie's like, forget about it, Mr. Kelly. Fine, I'll get the patty paper. Oh, wait.
Okay, I was just kind of eyeballing it.
No, I hear you. So, yeah, and then you'd connect those dots.
I don't think anybody's going to do
No. No, that's not very fun. Yeah, that's not very fun. Yes, you do get to use patty paper on quizzes and tests.
I got some patty paper.
Good for you. Excellent, Allie. Good, good. All right. This next one, example 3. Reflect across the y-axis first. All right. I want everybody to, if you have a highlighter, go ahead and highlight your y-axis. All right. We're going to reflect. Shh. All right, quiet. Okay. We're going to reflect this first point. We're going to go point by point. We're going to reflect that first point across the y-axis. So we go 1, 2, and it just takes 2 units to get to the y-axis. And so then we need to go 2 units away from the y-axis. 1, 2. And that's our first point. If this point is A, this point is going to be called A prime. And that's at 2, 7. Same thing with this. We've got this point. How many blocks is away from the y-axis? 2. 1, 2. So you go another 2. 1, 2. And that's your B prime. This was B. This is B prime. And that is 2, 2. And then finally, well, first, let's plot these so far. Let's put these guys in our columns. Image after reflection across the y-axis. So our negative 2, 2 turned into a positive 2, 2. Right? And our negative 2, 7 turned into a positive 2, 7. What's happening to our x values when we reflect it across the y-axis? Yeah, they're changing signs. This changed from a negative 2 to a positive 2. So did this, negative 2 to positive 2. What do you think is going to happen to this negative 8? It's going to become a positive 8. when you reflect something across the y-axis, the x changes from a negative or positive, or from a positive to a negative. So you start with xy, and you end up with negative xy. So that 8 would be 1, 2, 3, 4, 5, 6, 7, 8, and then up to 1, 2. So C prime is 8, 2. And if we put that whole triangle together, we get a reflected triangle. So that was across the y-axis, but what about across a diagonal? A diagonal. We're going to reflect this triangle across a diagonal. And the diagonal is the line y equals x. So remember, from algebra, you have your equation of your line, y equals mx plus b, where m is the slope. Well, guys, what number is in front of x? Well, it wouldn't be 0 because 0 times x is 0. 1. Slope is 1 over 1. What is the y-intercept? 0. Yeah, x plus 0. So it's just x. So we know it goes through the origin, 0, 0, and we know it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it just becomes a diagonal line. What angle did we say it made when we did the line of reflection and the line between the 2 points? A right angle, right? Well, let me ask you this. Is this a right angle? No, it's not. It has to have the opposite slope, which is negative 1, 1. So this goes from this point here, we're going 1 box, 2 boxes, 3 boxes, 4 boxes, 4.5. So we have to go 4.5 the other way. Here's my half, and 1, 2, 3, 4. So for this one, our point A prime here would be 1, 2, 3, 4, 5, 6, 7, 8, and negative 1, negative, oops, sorry, not 8, 7, negative 1, negative 2. 7, negative 2. Let's put that on here. 7, negative 2. Same thing for our point 2, 2 over here. You got it. 1, 2, 1, 2. So now our point is 2, negative 2. 1, 2, 1, negative 1, negative 2. So B prime is 2, negative 2. And RC, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So that's this point right here, which is 1, 2. Negative 1, 2, 3, 4, 5, 6, 7, 8. So for our new points, negative 8, 2 becomes 2, negative 8. And negative 2, 2 becomes 2, negative 2. So yeah, we just flip them. Whereas you start with, your pre-image is going to be x, y, And your image, when you're reflecting across y equals x, now this is only good for y equals x, is yx. So this is our pre-image, and this is our image. All right. Let's look at example 4. Reflect across. Well, this wants us to reflect across the x-axis, so I'm going to highlight my x-axis. And I'm going to start with 4, -2, and I'm going to go up 1, 2, and then I have to go up away the same amount, 1, 2. So 4, 2. I'm going to do 1, 5 next. There's my 1, 5. I go down 1, 2, 3, 4, 5, and so I have to go away the same amount. 1, 2, 3, 4, 5. And so now I'm at 1, -5. What do you think my 4, 3 is going to end up being? 4, -3. So whenever I rotate something or reflect, whenever I reflect something around the x-axis, the y changes. So it's kind of the opposite, right? So my 4, 3 is going to become 4, -3. And then I'll just connect my dots. That's 4, -3 right here. Nice catch. Okay, and then they asked me to reflect this across line y minus x. Y equals minus x. So y equals -1x plus 0. My slope is -1 over 1. My y-intercept is 0, so it starts here. And then it goes -1 up 1, negative back up 1, negative back up 1, negative back up 1. Isn't it just the same as what? Not necessarily. Not necessarily. Because let's take a look at 4, 2. What happens to 4, 2? We just go boom, boom. It's just one block away. And so now it's 1, 2 on the x-axis. And -1, 2, 3, 4. -4. So 2, -4. So not only have we switched it on this one, not only have we flipped it, but we've also done what else? Yeah, we've flipped it and we've changed the sign. So when it's across y equals -x, then you flip it and you change the sign. Now, for tests and quizzes, if you want to try to memorize those things, y equals negative x, or across the x-axis, that's fine. If you want to just graph it and then put it on there, then that's fine too. Either one of those works. But let's go 1, 2, 3, 3.5. There's my half. 1, 2, 3. So that's negative 1, 2, 3. Negative 1, 2, 3, 4. Negative 3, negative 4. And then 1, 2, 3. 1, 2, 3. And that's negative 5. Negative 1. All right. So switch them both and flip their signs. Flip them and switch them. And finally we get to example 5, and now we're talking about E prime. E prime is the image after a reflection across the x-axis. Find the pre-image of that point. Well, the nice thing is, since it's a reflection, you just have to do the same thing. We're going across the x-axis, so I'm going to highlight my x-axis here. And I'm going to find 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That's E prime. That's my image. That's my new. I have to find my old. And it's the same deal. You just count how far away you are from the axis that you're reflecting around. 1, 2, 3, 4, 5, 6. And then you go that same distance the other way. 1, 2, 3, 4, 5, 6. And so my E is for positive 6, and this is my old, or my original. But notice it's still the same idea. When you reflect something across the x-axis, what you change is the y, the sign of the y. Okay? F prime. Try F and G yourselves. F prime is negative 3, 2. It's the image after a reflection across the y-axis. Try that. Yeah. Yeah, that's fine. And find the pre-image of that. Highlight that Y. Stephanie, what did you get for your original F? Say it again? Oh, well, remember, if you're reflecting it across that y-axis, then your x is going to change signs, and that's it. So instead of negative 3, 2, what would you have? If you're just your x changed signs. Not negative 2, because that would be your y changing signs. You'd have 3, 2. Oops. Yeah, it would just be 3, 2. Remember, if it's reflecting across the y-axis, then it's your x that changes signs. All right, Edgar, what did you get for reflecting across y equals x? Well, that would be the case if we were reflecting across y equals negative x, right? Because with negative x, it switches signs and it flips them. But when you're just doing it y equals x, all it does is say it switches them, but it doesn't flip the signs. 7, 5, that's right. 7, 5. Okay. Let's take a look at that homework.